Hello, everyone. Welcome to Engineering Theme Week. We're going to give folks just a few moments to join us, and then we will kick off our session on our makerspace here at WashU. Thanks for joining. Once again, thanks to those of you who are joining us today to learn more about our makerspace here on campus. We'll give folks just another moment or so, and then we'll kick off our session and tour. All right, we will go ahead and get started. Good evening, good morning, wherever you are joining us from. Thank you all for joining us for the Makerspace session and tour today during WashU's Engineering Week. I'd like to start by acknowledging the indigenous culture of Missouri. Washington University and the city of St. Louis are located on the traditional and ancestral homelands of the Osage Nation, Missouri, and the Illini Confederacy. We honor them as we live, work, and study at WashU. My name is Elena, and I'm an admissions officer here at WashU, and I'll serve as your moderator for today's session. I'm lucky enough to be joined today by Dr. Ruth Akamoto and Dr. Charlotte Gertler, who will share more information on this foreign light metal microspace on campus. This is our third session of Engineering Theme Week. Throughout the rest of the week, we'll host a faculty spotlight and virtual class experience tomorrow, Thursday, and then a current student engineering panel on Friday. I'll go ahead and drop the registration links for the rest of these events into chat if you haven't registered and would like to join us. We also encourage you to follow us on Instagram this week, as we'll be sharing more information about engineering at WashU, as well as having current students answer more of your questions through the @WashU admissions Instagram. We will be recording the session and posting it on our virtual theme weeks page of our website, as well as all recordings from this week. If you have any questions throughout the session, please feel free to use the Q&A feature here in Zoom to submit your questions. We'll get to as many as we can at the end of the presentation. With that, let's go ahead and get started. Ruth, please take it away.
Thank you. Sorry. Okay, good evening and morning, as Elena said. I'm Ruth Okamoto, so I'm going to be presenting about the Makerspace today, and then kind of midway through, Charlotte's going to be taking you on a phone tour, so you can actually see, at least see the space from afar. So some of you may have a makerspace in your high school, but for those of you who don't, a makerspace is basically a place where for us at the university community, we can engage in hands-on projects and develop skills for turning ideas to prototypes. So we want to be welcoming, flexible, social, collaborative. Collaborative is probably the key word that we want to emphasize at WashU because it's a place where we're located, and also how we operate is designed to bring in people from all over campus, not just the engineering school. So our Makerspace mission is stated here, and I won't read it to you, but again, I want to emphasize that we are open to all students, faculty, and staff at Washington University. And that allows us to have people from the medical school, from the School of Occupational Therapy, art school, all coming over here and using our equipment. So we're located on the east end of campus in the new building for the mechanical and part of the complex for the School of Engineering in Jubal Hall. We're on the first floor. So if you come to Summers Welcome Center, you just need to look north and a little bit east and you'll see our building. And when you come inside the building, we occupy about 1,800 square feet. And right next to us is the Advanced Machine Shop, which I'm going to talk to you a little bit more about later. From the hallway, if you look in, we have a lot of windows looking in, and we also have windows on the outside. So we're in an extremely visible place. We have some of the best lighting on campus on sunny days. But basically, we also have space outside for people who want to talk together and then come in and actually work on a project or use the equipment. This is our Makerspace studio as it looked in February 2020, which is probably some of you remembers before the pandemic. And this is how we hopefully will be set up again this fall. You'll see in our tour today that we have fewer tables currently. So again, we're in a large open space, so we have work tables, and then we have equipment sort of strategically placed around the room. So to review some of the equipment that we have hand tools. So again, very basic. You just need to cut a piece of wood. We've got a saw for that. A laser cutter, which allows us to cut wood and acrylic. A bandsaw for cutting woods and plastics. An electronic bench where you can solder, repair electronics, and do other put together other types of projects. We have tool lockers. So these are places where we can store things like sewing machines, heat guns, and you check multimeters, all kinds of things that you can check out to use while you're in the makerspace. We have 3D printers on the north wall, and we'll talk a little bit more about that, and you'll see those on our virtual tour. Those are very popular. And oops, sorry, I skipped a slide. And the people who you see my face, and you probably also briefly saw Charlotte's face. So we are the staff in the makerspace, but we also have student staff who work in the makerspace. And we also have instructors from the classes that meet in the makerspace who are trained on how to use the equipment. So I think, Charlotte, we're all ready for your tour. So I'm going to stop sharing for a minute, and Charlotte is going to come out and she's going to walk around the space. So stop share.
Okay, so hopefully you can all see my screen. Basically, this is what you see when you come into the makerspace, and I'm going to give you a tour throughout it. So over here, we have our 3D printer wall. We have our large bed 3D printer, which is a Lulzbot TAS Workhorse. And then we have 7 Prusa printers. And these are our more general printers for someone who wants to start out and learn how to do 3D printing. And they can cover most of what you want to do for your 3D printing needs. If you have a more detailed project, we have our SLA Formlabs printer, and this will allow you to print in a lot higher detail, which you can see some of the parts right there. It is a little bit more expensive to print, but it is a really great piece of machinery. Underneath our 3D printers, we have a lot of drawers for storage. And then over on this side, we have lockers for storage, as well as a very large TV. And this is where our classes take place, and we'll have workshops presenting from up here. From this side, you can see all of our tables. We're currently still set up in our social distancing mode, where we have our tables more spaced apart. But before the fall semester, we're going to add more of our tables back and have a little bit more space for everybody. On this wall, we have our hand tools. And there's Ruth. And then down here, we have our laser cutter. And over here is our soldering bench. On this wall, we have our drill press and our bandsaw. And then finally, back to the beginning of our tour, in this little cubby area, we have a tool checkout area, which is a robo crib that allows you to check out some of our electronic tools. So that is a brief overview of the space. And now Ruth is going to play a video of the advanced machine shop.
Okay, sorry about the delay there. So next to us is the Advanced Machine Shop. And so at Washington University, we actually have 2 machine shops in the engineering school. We have what's called the engineering machine shop that is up in Erbauer Hall, which is one of our other buildings. And that is where all of our students who are in the mechanical engineering program take a machine shop practicum. That is, it's required for everyone to take a class on how to use the machines in the machine shop. So if you've taken that class, or if you've had some kind of advanced machine, or you've had a machine shop class in high school, you can take after you've taken that class, you can take a online test. And if you can pass that test, which demonstrates basic machining proficiency, then you can get training on the equipment in the advanced machine shop, which is next door to our studio. So we have 3-axis machining centers, CNC lathe, and a 4-axis machining center, among other items. So we're actually not going to walk through the virtual tour. We recorded this one in advance, so I will I'll give a narration as the video plays. So this is entering the machine shop. This is a milling machine. Again, we also have hand tools. This is the back, so you kind of get a sense of scale for how large the milling center is. This is our bandsaw. This is a coordinate measuring machine. And then this is the large 4-axis CNC. So CNC stands for computer numerically controlled. And what that means is basically you would design the parts that you were going to machine on a computer, and then you would use the computer to actually program the instructions for how the machine is going to cut the part for you. So if you notice there were doors on those, once you close the door, you don't touch anything. They just kind of run on their own. And this is a CNC lathe. So when you close the, this is not a CNC. This is a regular lathe, but it has an axis control. So you can see what you can program, you can tell it where to go precisely. So again, this equipment is not part of the makerspace. It is part of the makerspace, but it does require advanced training, and that's handled through Mr. Dennis DePella, who is the shop manager. But some of the students who use this equipment are members of our Formula SAE race team. They are making parts to drive a small 600cc car in an annual competition. That competition did not happen this past May, but it will be happening again next May. And by the time you're on campus, it will be back in full swing and you'll be able to participate in that. And that's something I highly recommend. I'll put my engineering professor hat on for a second at this point and say, learning, if you're interested in engineering, or even if you're just not going to be in another part of the university, getting experience with making things and hands-on, to me, that was like the moment at which I knew I wanted to be an engineer, is when I built something and it absolutely did not work. That was an eye-opening experience for me. Okay, so we've kind of shown you what our equipment is, and I want to move on to how the makerspace is used. So we do have courses that meet in the makerspace. Our mechanical engineering department has a required first-year course called Introduction to Mechanical Engineering Design. That entire course takes place in the makerspace. So this is a picture taken from the course. Again, this was pre-COVID. So students start out at this end and then quickly move on to being at these tables and building things, experimenting with things, and every week is a different during the first part of the semester is a different experience. And at the end of the semester, there's a multi-week project that uses the skills that you've learned. So if you take this class, you will learn how to use all of the equipment in the makerspace. Our senior design students, they have what's called a capstone project, and this is true of whatever department, all the departments in the School of Engineering. Our students are unique in that they actually have to build what they design. So this was a project from a couple of years ago. This was an underwater propelling unit. So they made a lot of the parts. They laser cut many of the parts and also 3D printed parts here in the makerspace for that project. There's also a first-year engineering class called EN 120, which I believe is still happening, and we do workshops for that. So again, another way is our goal is to get everybody introduced to the makerspace. You may just take one workshop in here. Your first year, you might not be back here till you're a junior or senior and you want to use it for something else, and that's fine. We just want everyone to have some exposure so that they kind of get the idea that this is a resource that's available for them. Okay, so sorry, I skipped a slide. Another important group of people who use the makerspace are student groups who come in and do workshops. So these could be orientation, or we teach them how to use this particular set of tools. So the graduate students in mechanical engineering wanted to learn how to solder. So we had a project where they soldered together LEDs and made a light up snowflake for the holidays. The Society of Women Engineering students made Valentine themed boxes. And we also partnered with a group you may hear about in another session called the Scandalaris Center. So they're kind of a hub on campus for entrepreneurship and innovation. And so they have a group, they have periodic workshops that are called Make and Take. So they came, we had about 35 people come down here, and they all designed tops, kind of customized lids for boxes that we laser cut while they were in the makerspace. And Sling Health is another group that spans both campus. It's a student group that spans our medical school and Danforth campuses. So they it's partnerships between medical students, engineering students, and other business students, all who are interested in projects that are related to health and wellness. So a group of them came and they built a light up sign. So you'll see a version of that in a slide in just a moment. And the third use of our makerspace is for research and individual projects. We are open for, again, we're open to all people, and you don't have to have your projects do not have to be related to a course or anything to do with research. You could also do something for fun. So we have a young woman last year who came in and she sewed dresses. She sewed little purses for her friends. She did a lot of sewing projects. We had a student who came in and 3D printed parts so he could put an electric motor on his bicycle. Another student who helped with first year orientation when he was, I think, a junior when this picture was taken. And they went out on a camping trip. He brought back a long stick and he cut it up into little discs, and then he laser cut like initials or logos on these for each of the students who went on the trip. So that was pretty nice of him. We had a student who made a puzzle for her friends. This is a graduate student who was working on a research project. So this was a lot of wiring in a prototype, but he was building something to basically simulate breathing so that that his research lab could test something called hernia mesh, which is used to repair diaphragmatic hernias. And this is something else. This is another project used for research. It's a microfluidics device. So again, we have a wide variety of projects, and so that's kind of what makes it really fun to work in the makerspace for us. These are we made some short video clips of different things happening. So this one first is a very time-lapse video of printing a model of Notre Dame Cathedral. So you can see that didn't take very long. It took several hours and real time. This is our laser cutter, and what we're doing here is we're engraving rather than cutting, and we're engraving on anodized aluminum to make a luggage tag with a Bayer logo on it. And this video here is a light up sign. So this is related to the project I described by Sling Health. There's LEDs that are soldered onto the circuit board underneath here, and they are programmed that that circuit board can be programmed to change the color of the LED. So you can program it however you want. You can have multiple colors. So we made this open sign for ourselves that change colors. Okay. Oops, it's going to go through the next slide. There we go. Sorry. What's going on here? Sorry. I know you're recording this, so it's quite embarrassing, but those of you who are watching the recording, I'm sorry, I hit the wrong button. Okay, the last thing I wanted to mention that happened in the makerspace during our COVID shutdown was we actually were the hub for building face shields for the university. So that's Charlotte right there. And she we basically she designed what we call the WashU Shield. And we made about 450 of those over a space of about 4 weeks. And we also partnered with a local community makerspace called Made STL. And we made an additional 450 face shields with their 3D printed parts. And these were delivered to the hospital, and to the medical school that's across the Forest Park from our campus. So again, that was an enjoyable thing for us in terms of learning how we could use our makerspace to actually make a lot of stuff rather than just prototypes. Okay, so going on to talking about training and consultation. So if you want to use our makerspace, we have training for all of our equipment. It's primarily online using a system called Safety Spot, which tracks the training that you've done. It's highly modular. The makerspace staff and the maker techs, who are our student workers, which is something you could do if you became a WashU student, they're also available to help with project ideas and assist on questions like, do I need to print do I need to have 3D, when I 3D print this part, does it need support? And there are certainly more complex questions that we can answer as well. During the pandemic, we started using remote 3D printing, and this is something that we will continue to do afterwards. It's been very popular, and basically allows you to design a part. If once you've taken the 3D printer training, you can log on to our virtual 3D printer database, prepare your file, submit your print to the queue, and then you just have to come pick it up when it's done. And you can actually, so this is something that allows people to, again, it's an accessibility thing. You don't have to be at the makerspace to use our equipment. For availability, for this coming fall semester, we'll be open on Monday through Friday, 12 to 5. And then we have classes in here Tuesday, Thursday, 10 to 4. There is some overlap. You can come in, people or anyone can come into the makerspace when we have class. There's just a limit on which equipment you can use. And then when we're about 3 weeks into this semester, we'll have extended evening and weekend hours. And that's partly as our makerspace staff are trained, and also as sort of projects progress through the semester, we have higher demand. So that concludes my presentation about the makerspace. I know you have some questions. I just want to highlight, if you don't get your questions answered during the chat, you can visit our website, which is jubilmakerspace.wistl.edu. And if you click on the Makerspace team link, you'll find pictures of me and Charlotte, and more importantly, our emails for further questions. So I think Elena looks like she's ready to jump in. Do you want me to stop sharing, or should I just leave the share on?
Go ahead, stop sharing so we can see your face. Okay. Thanks so much for sharing that, and thanks Charlotte for taking us through the actual makerspace. We do have some great questions coming in. As a reminder to students, you can use the Q&A feature if you have questions for Ruth or Charlotte about the makerspace. But first question coming in is, do you have to pay to use the 3D printers? And I would expand that out to kind of, what is the cost of using this, cost of materials for students?
That's a great question. So we do, we charge, basically, we do provide the filament for the 3D printers, and we basically charge at cost. It costs 25 cents for every 10 grams of filament. And we have many parts that only cost 25 cents. So basically, we have two ways that students pay. One is if they're involved in a research project, often the research project they're on will pay, and so that's called an interdepartmental charge. We also use BearBooks, which is our campus card, and people just swipe their card. And we have a system, it's what I call the library card system, because we have so many nobody wants to, especially with remote printing, people don't want to have to necessarily stop by to pay for a 25-cent part that we've put outside the makerspace. So we do have like up to $5 before you actually have to pay off your balance. So yeah, and then for the laser cutter, you can bring your own, it depends what the material are. We do provide acrylic, which is the only type of plastic that we cut on the laser cutter. And we also sell the little luggage tags, but you can bring different kinds of paper if you wanted to cut that. So you have to check with us, but a lot of we have students, especially from the art school, who bring their own material for the laser cutter, and there's no charge for using the equipment. It's just for materials.
Great. Can students come in anytime for any type of project? Do they have to sign up? And do they have to explain what they're planning on doing while they're in the makerspace?
So the answer to that is this year they did have to sign up. This coming fall, no, that you won't. You will be able to come in whenever we're open. We are only open when we're staffed, and that's just for safety reasons. And the only time you would have to still make an appointment is to use the laser cutter or the mill, or another piece of equipment called the Bantam mini mill. We have one of each of those, and they're relative. It's just to make sure you don't show up and somebody else is already. We don't have sort of contention, if you will, for those two. And as far as, do you have to tell us? Not really. Like, if you come in and you're sitting over here and you're soldering something, we don't have to know what you're soldering. On the other hand, if we see something that looks really unsafe to us, we will certainly ask you what you're doing. The training that we provide is really geared toward your safety. So we do have training, for instance, if you want to come in and use one of our cordless drills, we do have a little bit of training we ask you to do, not only for your safety, but the safety of those around you. But again, your projects are really there. They don't have to be related to school in any way, shape, or form. The one limitation we do have is you cannot print anything or make anything that looks like a weapon, and that's just a university policy.
Certainly, I think a good policy to have. You mentioned training, but students know if they already know how to use some of these tools, do they
Right.
have to do that training and kind of prove that they know how to do it before they can use them on their own?
So for 3D printers, the training is just online, and we have a way, you're basically, the way it works for us is if for those of you who are in the know, if you're an experienced 3D printer person, you know that you end up with something called G code. We'll look at your G code before we hit the print button. So we're not too worried about that. If you come in and want to use a drill press, and most of the training is online, but our drill press, we will have a brief checkout the first time you come in to make sure it's safe for you to use the drill press. So anything where there's kind of a risk of you injuring yourself or someone else, and for our laser cutter injuring our equipment, we do have like a very short amount of in-person training, this kind of that check off to make sure you're okay to use it. But most of our training is done online and in the comfort of your dorm room or wherever you would be on campus.
So pretty easy for students to do that online.
Very, very. That's kind of one of our goals, is to make low barrier to entry is our slogan, right? So
that transitions me nicely into our next question. Do first year students have the same access to the equipment
yes.
as our upperclassmen students?
Yes, there's no difference. In fact, you can be, as we've mentioned, we're open to non-students. So we have faculty and staff who come in here and use the equipment. So yeah, the first year, there's beginning of the year, again, by the time you would arrive on campus, since you're all, I think, mostly rising seniors in high school, things may have changed yet again a little bit. But in our current setting, we do have an online orientation that everyone does. Once they've done that, they can come in the makerspace, and once they've done the training for a particular piece of equipment, they can use that equipment. Obviously, things like hand saws, those you can walk right in and use them on day one. But if you're going to do laser cutter, you're going to do the laser cutter training and then do a laser cutter in person, what we call check off, before you actually start using it. But it has nothing to do. It's open to all levels of students equally.
Great. A question about sustainable materials. So do you find that students are looking to use sustainable materials? And a question specifically if they're able to choose eco-friendly filament in 3D printers?
So that's a great question. So a few months ago, we started partnering with a local startup, and we are recycling our PLA filament. And they just emailed me a few days ago offering me recycled filament to purchase. So we will hopefully have that up and running by this fall on several of our printers. Mostly it's the issue with the ecofilament is just making sure that it's of the same quality. But I would say most of our students, especially students who are making something for a class or project, they're fine. The ecofilaments are often kind of gray or black because they're a mix of all the different colors. But if you're fine with that, then I would fully expect by the time you arrive on campus, we'll have plenty of eco-friendly filament options. So yeah. And the recycling is another important component, because obviously 3D printers do generate a lot of waste, I guess.
Yeah, and I know a lot of our current students are interested in sustainability and things like that. We're happy to hear that it's kind of in the works. Question about, are there any popular student electronic or robotic projects that you've seen?
Well, I have had I had a student in a few weeks ago making his own keyboard, and I was like, wow, that seems really hard. You can just go to the local computer store and buy a keyboard. He's like, oh no. So he's explaining to me, for gaming, you can program that you can program this keyboard to be the way you want it. So that's definitely something that we've had students coming in and working on. I'm trying to think what other ones have been popular. We've had people, most people are doing projects that are related to things like Arduinos. So not so much robotics, but I'm sure there is robotics. We have IEEE, which is the electronics, it's the electrical engineering student group. So they have a robotics competition that they put on, and they have a kind of a club that's for robotics. And I know they talked to me about coming and using our space this fall. Again, our student groups have suffered a little this past year because of COVID. So for sure, the student groups are very, into doing all these things. And again, I highly recommend anyone whether you go to engineering school here or whatever university you choose, get yourself involved in hands-on projects as early as you can. So
it's great advice. It's great advice, especially if you're thinking, do I want to do this long term or just for a while? Having that hands-on experience teaches you very quickly. A question about kind of within the engineering curriculum, do
Mhm.
kind of all students have either coursework or opportunities to use the makerspace, or is it more geared towards mechanical engineers?
Um, so in terms of coursework, right now it's primarily mechanical engineering. However, biomedical engineering, although they don't they have their own, there are both, I should be clear that we are a makerspace for the whole university, but they're also what I would call curricular mini makerspaces in many of the departments. So electrical engineering has a second year course, and they basically have a smaller classroom that's set up like a mini version of the makerspace. They don't have a laser cutter, but they have 3D printers. They have a lot of electronic stuff. BME has something similar for their third year class. They have in their junior level lab class, they learn electronics and they program Arduinos, which are some of the same things we do in the makerspace. So I would say all the engineering departments have at some level opportunities, even if they're not specifically in the makerspace.
Great. And then another question about training. Do students have to do the equipment training every single year, or can they just do it at the beginning of first year?
Well, we would recommend, for the most part, you repeat the training each year. We don't necessarily, if the training hasn't changed, we don't require you to do it again, except right now, every year you have to redo the kind of the orientation and safety training. There's two good reasons for that. One is we want you to kind of remember what the rules are, and B, we're changing the rules every year. So we need to make sure you know what the current rules are in terms of access and so forth. So, but you can go back and watch, since the training is online, you can always go back and watch the video again and make sure you feel comfortable with the equipment. Our key goal is always when we see someone who doesn't look like they're comfortable doing something, that's when we're going to walk over and just kind of check in with you and make sure you're feeling that you do know, that you have had the training and that you feel comfortable with whenever you took it, that you remember enough of it for it to be useful to you.
I think safety first is a good motto for the makerspace, and so making
Yeah.
sure people feel comfortable with the machinery and equipment is most important. If students happen to develop a successful product out of the makerspace, do they own the intellectual property if it was made in the washroom space?
So the answer to that is for undergraduate students, the answer would be yes. For graduate students, it depends what you're doing and who's sort of paying who's paying for what you're doing. So when graduate students work on research projects, usually that is intellectual property that they don't have exclusive ownership to, but it can be licensed, for instance. I mean, so the university will file patents on the behalf of people for graduate students. For undergraduates, the university disclaims basically any intellectual property rights and things that you develop in a class or on your own time. And for the research, then it's going to be a little bit different. Even for undergraduates, it could be a little bit differently if you were being paid to do your research. So hopefully that's not a super clear answer, but that's about the best one I can give. So
yeah, it was helpful. Thanks. And then a question, can students be assigned a mentor from the engineering school to follow up with kind of testing to match their original idea, even if it's not class related? I think that's an interesting question. I don't know if you have that.
Yeah, so we don't really have a mentor. So you're thinking about like a design mentor, or it sounds like the person who asked the question, I'm envisioning this as a design mentor. So that's somebody who you can come in and get advice. So we don't have a formal system for that. One of the things I do enjoy about my job is giving people, I'm very happy to give people advice. Maybe they don't always want my advice. But just kind of coming in and informally talking with people like, okay, I'm trying to do X, and so I've had quite a number of experience where people come in, I'm saying, I want to do this. And we talk about, is the way you want to do it necessarily the best way to do it? Or is there another way to do it? And so sometimes people switch, sometimes they don't. Sometimes they've actually, given consideration. So there's informal mentoring that would go on with us as the Makerspace staff, but there's not really a formal mentoring program in place right now.
Great, thanks. And then do you know if students who are on financial aid at the university have to pay for materials, or if there's any financial support or scholarship available?
That is something we haven't dealt with at this point, mostly because the costs that are incurred by most of our students are extremely low to the, I would say most students who've spent Bear Bucks money have spent less than $10. A kilogram of filament is $20 or $25. So it's quite a bit, but that's if that we have in the engineering school, I think that Chris is there, the engineering projects board, which has means for you for groups of students to apply to get money to help build things. But for individual students, I'm not sure what the situation would be.
Yeah, and I'm not sure either as kind of the admissions office, you can definitely email us and we can work with financial aid to see if that's something that was included in any of the cost of attendance, scholarship, or financial aid. Just wanted to put that out there.
Yep.
All right, I think that is all of our questions from everybody.
Okay.
I appreciate both of you taking time to share all that great information. Really enjoyable to hear all about the Makerspace, and excited that students will be back on campus this fall and be able to use the space. And that hopefully students that are attending the session will get to use the space in the future. As a reminder, you do not have to be an engineer to use the space. So even if you end up coming to WashU and not being an engineer, you have that space available to you, resources, support, and everything like that. I will drop all of the links into the other theme week events this week. As a reminder, tomorrow we have our virtual class experience with Dr. Witter. It'll be a really, really awesome class, a great kind of glimpse into what engineering coursework would look like here on campus. So make sure that you're attending that if you want to see what a class looks like. And then on Friday, we have a handful of students that will be doing our current student panel. They represent lots of different majors and programs on campus within the engineering school. So definitely make sure to join that student panel. Thanks again to Ruth and Charlotte for joining us, and thank you to the audience for tuning in. We hope you have a great rest of your evening and a great rest of your week. Thanks, everybody.
Yep. Bye-bye.